Hey everyone, Dankman here. So today we're going to start a new unit. So this is unit 4, and the title of this unit is Systems of Equations. Okay? And actually I'm going to start this unit with something of a little story. Not like a story with a plot and characters, but a story about how we're thinking about the mathematics. So we have this thing called an equation. For instance, we have an equation like 3x equals 15. And if we want to talk about what a system of equations is, we have to at least know already what an equation is. So what is this 3x equals 15? Well, if I let x, the variable, have a value of 5, then what happens is I plug in 5 for the number x, and I get 3 times 5 on the left, and 3 times 5 is 15, and 15 is indeed 15. And so this equation is satisfied by the solution x equals 5, which means that the left and the right side of the equation come out equal. This is a single variable equation, okay? And to work with these systems of equations, we're actually now going to look at an equation that has 2 variables in it, okay? So let's take, for example, the equation y is equal to 2x plus 3. Okay. Now, we actually know a lot about this equation. This equation makes a graph that we understand. So let's peek at that graph, okay? That graph looks like this. Okay, we have the x-axis and the y-axis. Okay. We know that the y-intercept of this line will be 3, and we know that the slope will be 2, and so we can plot these little points. And when we do that, we have this line. And the question that I'm gonna ask and talk about now is really, what is this line? Okay? And what does it have to do with these properties up here where an equation can have a solution? Okay? So let's take a look at this line. So I'm going to pick up something that you guys know about, which is called an ordered pair. Okay? I'm going to pick this ordered pair. So this point has 2 coordinates. They're 2 and 7. Okay? All right? And those are in order, the x coordinate and then the y coordinate. So I'm going to show you something about that coordinate pair 2, 7. So you take any coordinate pair that goes x comma y, and in the case of 2, 7, what we're going to do is we're going to plug in the y value, 7, and we're going to plug in the x value, 2. So you can see x should be equal to 2, so I substituted the number 2 in for x, and y should be equal to 7 according to this coordinate pair, so I substitute the number 7 in for y. Okay? And if you evaluate the right expression of this equation, you get out 7. And so what you get is you get an equation that's satisfied. Okay? So I picked a point on this line, I took its coordinates, I plugged those coordinates into the equation, and those coordinates solved the equation. Okay? Could pick another point from that line, like the point 1, 5. Okay? And I could take the coordinates 1, 5, and I could replace the variable y with the number 5, and I could substitute in the number 1 for the variable x. Okay? On the left I have 5, and on the right I have 2 times 1, which is 2, plus 3, which is 5. So again, the equation is satisfied. Okay? Now, if instead I picked a point like 1, 2, okay? Well, if I take that point 1, 2, and I take its coordinates, I put 2 in for y, and I put 1 in for x, what happens is on the left I have 2, and on the right I get 2 plus 3 is 5, and that is not a solution to this equation because the equation is not satisfied by this coordinate pair 1, 2. So this equation is unique and different than a single variable equation because instead of just one variable x, it has two variables together, x and y. And instead of just one solution, like x equals 5, we found at least two solutions already. And we've also found that sometimes a pair of numbers is not a solution. So you have solutions that satisfy the two-variable equation and ordered pairs that are not solutions and do not lead to the left and the right side being equal. And in fact, if I look at these solutions right here, 2, 7, and 1, 5, they're not the only solutions. I picked those 2 points from the line and I got their coordinates. And if you go around picking any point off of this line, you could pick 0, 3, you could pick -1, 1, you could also pick in between whole numbers, for instance, like right here, you could pick the point -3/2, 0. And if you plug -3/2, 0 into the equation, lo and behold, the equation is satisfied. And so the thesis here is that there are infinitely many solutions to this equation, okay? All of them are pairs of numbers that match together, an input-output pair, okay? And all of them match to points that are on the line. So the line is a picture of all of the infinitely many solutions. Every single point on this line represents a new solution that you could put to the equation y equals 2x plus 3. And any point that's not on the line does not solve that line's equation. Okay? So two variable equations can have many solutions. Okay? And points on a line solve that line's equation. And points not on that line do not solve the line's equation.